starting our new unit here. In chapter 13, we're looking at trigonometric functions. And in this first section, 13.1, we are exploring periodic functions. We're going to find some vocabulary that goes along with periodic functions and figure out really what a periodic function means, what it means to be periodic. Before we get there, see these pictures here? What do these situations have in common? We have the earth and the sun, a heart beating, a swing, and a wave. What do they have in common? Well, all four of these pictures, if you realize it or not, all four of these pictures are things that repeat. They're all things that repeat regularly. It takes the same amount of time for the earth to move around the sun. If you think of your heart beating, your heart beats at roughly the same beat, or roughly the same pace. If you're swinging on a swing, go back and forth, back and forth. And if you think of the waves and tides, that happens at the same time. So all four of those things repeat regularly. And that is what a periodic function is. So periodic function, I'll add that in here. You'll want to make sure you're writing this vocabulary down so you can come back to it later. And really, that's a lot of what this section is. The periodic functions are functions whose y values repeat at regular intervals. And the period is how long it takes for the function to start repeating. And I should add on there, that's how long it takes on the x-axis for the function to start repeating. All right, let's look at an example. Is the function periodic? If so, what is the period? Well, let's look at this graph on the left first. Is the function periodic? Well, if we look back at that last slide, for it to be a periodic function, the y values have to repeat at regular intervals. And looking at this one, I mean, we have a pattern. We go up 2, down 1, up 2, down 1, up 2, down 1, but my y values aren't repeating. So this first one is not periodic. Okay, let's look at this next one. Is this one periodic? Do my y values repeat? Well, if you look at the top here, we start at the top of a mountain, go down, we hit the bottom, and then we kind of do this, I don't know, level off pattern, and then come back up, okay? And hey, that pattern repeats. So since that pattern repeats, our y values repeat themselves, and it's a regular interval, those, I don't know, those repeating y values happen at a regular spacing. That means that this is a periodic function. Now we have to figure out what the period is. And again, the period is how long it takes on the x-axis for the function to start repeating. And you can look at any of your key features on the graph. I usually like to look at either the highest point or the lowest point on the graph I tend to think of that as the easiest, like identifying feature. So if I start at the highest point here, my next highest point is 10 away. So my x value here is 0, my x value here is 10. So that means the period is 10. And again, you really can look anywhere on the graph. If I looked at the lowest point from the length on the x-axis, from my low point here to my next low point, well, this is 4. We're going up by 2, so this is 12, this is 14. My lowest point's at 14 here. From 4 to 14 is still 10, so the period is 10. The reason I like to look at either the highest point or the lowest point is because if you look at something like the x-intercepts, it can be kind of deceiving. Like if I looked at my x-intercept right here, my x-intercept at 2, I might think, okay, my next intercept is where we start repeating. But my next intercept, well, from here to here, my pattern hasn't started repeating yet. When x equals 2, I have an x-intercept, my function's decreasing though. The next time that I'm at an x-intercept where my function's decreasing isn't until we're at 12. So from 2 to 12. We still have the period of 10, but again, since we have another x-intercept in between, sometimes it can be kind of tricky. Okay. 2 more vocab words that go along with our periodic functions is the word midline. And a midline, it's kind of a self-explanatory vocabulary word, but it is a horizontal line that divides the periodic function in the middle. Okay, and I'm going to add to that midline, it doesn't necessarily make the graph symmetric. It's not always a line of symmetry. Sometimes it is, sometimes it isn't. And then amplitude, our last vocab word here, the amplitude is the distance from the midline to the highest point on the function, the highest y value. And really, I should add to that, it could also be the lowest point on the function. If you start at the middle, start at your midline, that distance from your midline to the top and the distance from the midline to the bottom should be the same. Kind of similar to the way our focus and directrix work with our vertex. Okay. Now, with these vocab words, let's look at one more example here. We have this periodic function. I want to find what is the amplitude of the periodic function and what is the equation of the midline. All right, the amplitude and the midline. Well, let's maybe start off with our midline. And then once we find our midline, our amplitude will be a little bit easier. So let's think, okay, where could I draw a line? I think I can do that in here, yeah. Where can I draw a line on my graph that's in the middle? That divides our y values, or divides our function in half. Well, that's not it, right? There you go. This line does not divide my periodic function in half. That looks pretty good though. So my midline, my y value here, is at -1/2. And since it's a horizontal line, my equation is y equals -1/2. If you ever are like, oh shoot, with these y values, I don't really know what that number is going to be, an easy way to figure it out is to take your highest y value, or your maximum y value, plus your minimum y value, and divide by 2. So in this case, our maximum y value was 1, our minimum was -2, divided by 2. 1 plus -2 is -1, divided by 2 is our -1/2. That's an easy way that we can figure it out. Now then our amplitude, let's think about how far is it to go from -1/2 to our highest. Well, it's going to take 1/2. So our amplitude is 1/2, or 3/2. So again, a lot of this first section is figuring out some vocabulary, seeing the words amplitude, seeing the words midline, and just understanding and seeing what a periodic function is, as well as the word period. So there you go.